So we're going to be working on this class opener, which is dealing with piecewise functions. And what is a piecewise function? It's just a couple of pieces of functions put together. And you, like g of x right here is a piecewise function. And it's really composed of two functions, two pieces of two functions. And they're both linear functions because they don't have a power of 2 or a power of 3. They're a power of 1, which makes them linear. So both of them are linear. Anyway, the first question on the opener was to evaluate when x equals 1. Now, in Algebra 1, evaluate, and in any math class, evaluate means to plug in your value and work it out. So we need to plug in the x value of 1, the input of 1. So the correct notation that you guys should do, if I go to the side over here, is going to be g of 1. Okay, so everybody should write that down for number 1. G of 1 is saying that we're going to plug in 1 into the g of x function. Now the question is, where do we plug it in? Into this top one or to this bottom one? Top one, because when you say that you're plugging in 1, you need to plug it into this one if your x value is less than or equal to 1. And of course, 1 is equal to 1, so you're going to plug it into this one. You cannot plug in 1 into this one because it says that your x has to be greater than 1, and 1 is not greater than 1. So we're really plugging it into the top one, and that's going to be g of 1 equals 2x, but I'm putting parentheses there, minus 1. And of course, we're plugging in the value of 1 in there, so there's the 1. And that's really 2 times 1, which is 2. Take away 1, which is 1. So the answer to g of 1 is just 1. Cool? All right. So let's go for the next one. It says also evaluate for x equals 5. So we're now going to plug in 5. So that's going to be g of 5. G parenthesis 5, that's just a notation stating that we're going to plug in 5 into the g of x function. And of course, where does 5 fit? Well, 5 is not less than 1, 5 is greater than 1, so we're going to plug it into the bottom one. And the bottom one reads 3 times x plus 1, and of course we're plugging in the 5 that they want us to plug in. So the answer will be 15 plus 1, which is 16. So g of 5 is equal to 16. That's what you're going to be seeing on the final exam, so hopefully you guys understand how to do that. Anyhow, the more interesting part would be to graph this piecewise function. So we need to understand that the g of x function is composed of two linear functions, so it's kind of like if we're going to graph two lines. So the first line, we're going to look at it as y equals mx plus b from Algebra 1, right? The slope is 2 over 1, and the b value is negative 1, which means the y-intercept is negative 1. So if we go to negative 1, and we put a dot right there, and then from that point, I go up to 2 over 1, I put a dot right there, and I connect the dots, I have my line. I hope that makes sense to everybody. I hope you remember that from Algebra 1. Now, if I wanted to extend my line, let's say to the left, instead of going up 2 over 1, I'd be going down 2 over 1 the other way. And it all depends how long you want to make your line and what direction of the line you actually want to see. Now, I could continue extending this line this way and also this way. However, I need to look at my domain value. And I probably should have done that before actually drawing my line. So if I look at my domain value, it's telling me to look at the x values that are less than or equal to 1. So if you think about the x-axis right here, and it has to be less than or equal to 1. So here's 1. So maybe I should do this. Let me do this. There it is. If I cover up everything that's on the right of 1, then I really will only see the values that are less than or equal to 1. Does that make sense? So I really only see this part of the line because it's specifically telling me only look at x is less than or equal to 1. So I'm not looking at anything that's on this side because normally it would extend this way forever, but since I'm only looking at the values that are less than or equal to 1, I'm only looking at what you see right there of the red line. Now, let me get you guys to understand this. If this would have said less than or equal to 0, then guess what? We would only see this part of the line that's on the left side of 0. If this would have said x is less than or equal to -1, guess what? You would only see that part of the line down there. Does that make sense? Anybody? Tell me it makes sense. Okay, a lot of sense. I hope so. Okay, so let's now move on to the next graph. And the next graph, let's graph it in blue. And the next one is y equals 3x plus 1. So where does it cross the y-axis? It crosses at 1. Let me put a blue dot right there at the y-intercept of 1. And from that point, what do? I go up 3 over 1, right? So let me move this out of the way. Whoa, that's so not good. There we go. So we are going to go up 3 over 1. 1, 2, 3 over 1. You put a dot right there. And you're supposed to draw this line. However, if we look at the domain, it only wants the line that are at the x values that are greater than 1. So here are the x values that are greater than 1. It's on this side of it, right? So in this case, it would be like if you didn't want to see any of this over here. So you have to keep going up 3 over 1. So this is going to kind of take us off the graph. 1, 2, 3 over 1. So you end up with this line up here. Okay? And it does continue forever. Now this one does have x is greater than 1, not greater than or equal to, which would mean that this should be an open dot right here. Even though I actually drew it solid. Let me see if I could fix that. There we go. So that's our graph. It's two pieces of linear functions, right? Two pieces of a line. And they don't have to be connected, as you can see. But it is continuous because even for the x value, the input of 1, your output is 1. Even though there's a gap on the y's, there is no gap on the x's. Does that make sense?
Yes.
I hope so. Okay, so let's move on to the next one. So on this one, you have 3 pieces of it. And of course, the first thing they ask you to do is to evaluate for x equals -1 and x equals 3. So you're going to say h of -1. And where are you going to plug in the -1? Into the first one, the second one, or the third one? Where does it fall? Is -1 less than or equal to 0? Yes. Is -1 between 0 and 3? No. Is -1 greater than 3? No. So it has to be the first one. And again, you write it exactly the way it is with parentheses instead of the variable. And you're plugging in a -1. That's what they want you to plug in right there. And when you work it out, -1 squared, that's 1, but this negative sign comes down right in front of it, and -1 take away 1 is -2 as your output. So h of -1, that really equals -2. h of -1 really equals -2. And again, that's the type of question you're going to see on the final. So if we move on to the next one says plug in 3. So you're going to have h of 3. So h of 3, I want to do my work down here. H of 3, where are we going to plug in the 3 according to our restrictions? Would it be the first one, second one, or third one? Does 3 fit right here, or right here? In the third one, so we're using this bottom one. So we're going to plug in 3 into the bottom one because 3 is greater than or equal to 3. It's equal to itself, right? So we're using that bottom one, and the way to use that bottom one would be to rewrite it exactly the way it is. Inside, you're going to have a -3 and then squared and then -2 at the end, and we're plugging in 3 right there. So 3 minus 3 is 0, and 0 squared is 0, and 0 take away 2 is -2. So h of 3 really does equal -2. So those are your answers. That's what you're going to have to do on the final. Now the more fun part of this would be to graph this piecewise function. So we have this piecewise function h of x, and we should all know that this is a parabola that's opening down. It's not wide, it's not narrow, it's a regular parabola. As a matter of fact, we should know the pattern of that parabola. It's 1, 1, 2, 4, 3, 9. Like I said, it's opening down instead of up. Not only that, it has a k-shift that's -1. So my vertex is now at 0, -1. And if you did the pattern 1, 1, 2, 1, 2, 3, 4, well, it's going to be a little bit further down. 1, 2, 3, 4 is down here. So there is your parabola right there, if you were to trace these dots. But I'm not tracing the dots yet because I want to know what domain value I want. And if I look at the domain value, it says x is less than or equal to 0. So you want everything that's on the right or the left side. You don't want the x equals, you don't want the x values that are greater than 0. You want them that are less than 0. So you're only looking at the left part of this parabola. Okay? Now if you move on to the next piece, the next piece is a linear function. I want to do that one in blue. That linear function crosses at -1, and you go down 1 over 3. So it crosses at -1. I want to put an open dot because of my domain. And it goes down 1 over 1, 2, 3. So I end up right here at this one, and this is also an open dot. I shouldn't have put a solid dot, sorry. But there's your solid line from there to there. And that's only showing you this piece from 0 to 3. And for my final piece, I have another quadratic, which is another parabola. This one's opening up because it's a positive a value, and it does have a hk shift of +3 and -2. So your original parent graph, and I want to graph this one in black. Your original parent graph has the origin here, 1, 1, 2, 4, 3, 9, you know, and it's opening up. But this new vertex gets shifted over to the new hk value of 3, -2, and that ends up at that same point. Now, of course, we know that the vertex is now here, and we know that the pattern is 1, 1, 1, 2, 1, 2, 3, 4. So here's our vertex, or our vertex and that half of the parabola. Now normally I would draw my complete parabola like this, but it only wants us to show the values that are greater than or equal to 3, which means that you don't want to see the left side of this parabola, you only want to see the right side of the parabola. So there's your final graph. It looks like a pretty crazy continuous function, right? Half a parabola, and then straight line, and then half a parabola. It doesn't always have to be continuous. Sometimes there'll be a disconnect between the graph. Like you could have had a solid dot right here and then an open dot over here with something else, right? But in this case it looks like one giant continuous graph. I hope this helps with piecewise functions.